Hi everyone, I've got a question on the board. This is a 12-mark question from the Spring 2017 series. This is a big question at the end. So the question itself is saying analyse the final circuit shown in figure 1 and evaluate the suitability for loading, which is your current, your earth fault protection. So two things we're looking at there. So loading and earth fault protection. So it's a two-part question. So this will work in a sequence and we'll take it step by step, which should make it quite straightforward. So the first thing I noticed with this question is the final circuit at the end. It's got a little symbol there. It's got 106 millihenries written there. So when I see something that's got henries, it straight away means it's inductive. So this is an inductive circuit. Could be capacitive, could be anything you want, but as soon as you get anything that's inductive or capacitive, it means there's a little bit of an equation to work out first. So what we're aiming for is to get the load in. So we're looking at getting a current. To get current, we're looking at a few things. So current is your I equals V over Z, because AC will be resistance in a DC, but AC voltage over Z. We don't have an impedance value, so we need to work impedance out. So to get impedance, we're looking at Z equals the square root of R squared plus XL squared. Okay, so to get to this point, we're going to have to work out what XL is. So XL equals 2 pi times frequency times L, your inductance. So for this, we know what 2 is, it's a given factor. Pi is 3.14. Type in a calculator as a pi symbol as well. Frequency is not given in this question, guys. So what you need to consider with this, it's an AC UK system, so frequency would automatically be given as 50 Hertz. Times by our inductance. It says 106 millihenries. So 106 millihenries. So milli is times 10 to the minus 3. Types of that. So times 10 to the minus 3 because it's milli. I'm going to put this in the calculator on the right hand side. So 2 times by pi, which is at the bottom. The EXP button's got a yellow pi symbol above it. So if I shift, get the pi on the screen, times by 50, or frequency, times by 106. And to get it times 10, we're going to use the EXP button itself, so the expression button. EXP, we're going to use the minus that's in brackets, and then 3. And there we are. So it's given us an inductive reactance, so our XL is 33.3 ohms. So this is reactance now, so X is reactance. So we can now use this to work out our Z. So if we're looking at what we've got above, so Z equals the square root of R squared plus XL squared. So we're looking for a resistance value. So square root, resistance is actually given in this. It might seem a little bit blurred for you guys watching there. That's his 25 ohms. So I can put that into my equation. So you can't see it does say 25 in that small box. So 25 squared plus XL squared, which was 33.3 squared. Okay, so we'll put that in the calculator. So the square root symbol, make sure this covers everything when you start typing. So 25 squared plus 33.3 squared. And if you look at that, it gives me 41.64. 41.64, and that's ohms. Okay, so Z equals 41.64 ohms. So the next stage, what we need to do, guys, is to go and look at our current. So current is I equals V over Z, which I asked for originally. So we'll do that underneath. So current V over Z. Again, the voltages are given in the UK as 230 volts. 230 divided by 41.64. Okay, and that gives us a current. So when I go to a calculator, I'm always using a fraction symbol, saves making any mistakes. On top, 230, underneath, 41.64. Okay, and it gives me 5.5 amps. Okay, the first part of the question says, what's the suitability for loading? So I can see straight away that this is protected by a 6 amp Type C circuit breaker. Okay, so Type C, 6 amp. So my design current needs to be less than 6 amps, which is agreed. We've got 5.5 there, so 5.5 is less than 6. So therefore, it's suitable for loading. I can look at this and say, the circuit breaker is bigger than the design current, so it's acceptable. Perfect. So next thing we need to do, guys, we need to look at the earth fault protection. And to do this, it's a split again. So we've got our ZE value, which is there, which goes up to our consumer unit. So our main earth terminal, ZE goes there as 0.2 ohms. Then we've got a circuit going to a subboard, which is a 16 mil with a 6 mil CPC. Then from that board, going on 6 ampere, go to 1.5 and 1 mil cable. So what we're going to work out now is the R1, R2 value. So the R1, R2 value is from this, we've got a 16 mil and 6 mil. So 16 millimeter, 6 millimeters squared. So it's my live conductors, and that's my CPC. So from this, we can work it out. So if we go to the on-site guide, what we'll do here, guys, I'll open up an on-site guide on the screen. Jump back over there. Read the Vex book, get the on-site guide back. I'll jump back to the split screen. I'll load my on-site guide on this side. There we are, so the on-site guide. So in the on-site guide, we're on page 196. So I can go down the on-site guide and I can have a look, and I can see a 16 mil cable there with a 6 mil CPC, has an R1, R2 milliohms per meter of 4.23. So 4.23 there. So 4.23. And we need to times this by the length. So the length of the cable is 15 meters. So we times this by 15. And this cable is flat profile, 70 degrees sheathed, so it's twin and earth cable. So this has got a rating factor. If you go to the on-site guide, go to page 198, it's 70 degree thermoplastic incorporated in a cable or bunch, so it's got a correction factor of 1.2. So we times this by 1.2. And if we go back to our initial table, if you look at the top, it states milliohms per meter. So to get milliohms, we divide the full answer by 1000. Okay? So if we load the calculator back on the screen, onto this side, clear it off. So a fraction symbol, 4.23 times by 15 meters times 1.2 our correction factor, divide the answer by 1000. And it's 0.076 ohms. So my R1 and R2 for this part of the circuit is 0.076 ohms. So that's for this bit here. So 0.076 ohms. So now we need to do exactly the same for the final circuit, the 1.5 and 1 mil over this side. So we're doing exactly the same again. We'll go back to the on-site guide. So the R1, R2, 1.5 millimeters squared live, 1 millimeter squared CPC. Okay, so I'm going to load the on-site guide back up on the screen. And we zoom out a little bit. So 1.5 over 1 mil CPC, 30.20. So we're doing exactly what we've done above. 30.20 times by the length. So the length of this part of the circuit is 25 meters. So 25 meters in there. So times by 25. Again, we've got the same correction factor. We've got a correction factor. It's 70 degree firm plastic. It's incorporated in a cable because it's twin and earth. So we're timing it by 1.2. We're then going to divide that into by 1,000, obviously because it was milliohms. So I'll pull the calculator back on the screen here. Clear it off. Fraction symbol again, as we always do. 30.20 times 25 times 1.2. Bottom of the equation divided by 1,000. And it's 0.906. So considerably more than the one above. The reason being it's a lot smaller cable and the cable is longer as well. So the R1 R2 plus R2 is 0.906. So what we're looking at now is a ZS is what we want for this. So ZS equals ZE plus R1 and R2. So we need ZE. So ZE is given in the question at the beginning as 0.2. So 0.2 is my ZE. Okay, I'm going to jump on a different colour pen so it's easier to follow. So ZS equals 0.2 plus my R1, R2. I actually have two R1, R2 values here now. I've got 0.076 and 0.906. So we'll add them both in as well. So 0.076 and 0.906 as well. So if we add the three of these together, so 0.2 plus 0.076 plus 0.906, and it gives me 1.18. So 1.18 ohms. Again, anything impedance is measured in ohms. Okay, so now what we need to look at is what's the maximum. So that's my measured. So measured ZS. So my maximum ZS. Where are we going to find this from? So where are we going to look for this? We're going to look into the regulations. So BS 7671, the wiring regs. So we'll jump out the on-site guide. We'll jump in the wiring regulations. So looking about page 61 on this one. So page 61, I'll move this a bit bigger. So if we go back up to the question, in green over here, it says 6 amp type C. So if you look on this, so here we've got fuses. So 6 or 8, 9 is what we're looking for. So these are all fuses. So BS88-2 fuses, BS88-3, 3 or 3 6s. So we'll go to the next page down. At the top, we've got type B breakers, but we want a type C. Type C breaker is what we're looking at. And it's 6 amp specifically. It's given to us as 6 amp. Underneath that, it's got 3.64. So the maximum ZS we're permitted is 3.64. So I'll make that a bit smaller. We'll move across. So 3.64. So all we need to do is a final written statement on this question. We can say measured ZS equals 1.18, which is less than maximum permitted ZS of 3.64, so is acceptable to comply with what we're actually asking. So if you look at what it's asking, we're answering the question earth fault protection. So make sure you answer the question to comply with earth fault protection. So make sure you show every bit of working out, every step-by-step guide, number it up if you like down the side. I haven't, when I've done this, I've used different colours, but you do step 1, step 2, step 3, step 4. Final answer, what I would do at the bottom is underline my final answer, or make some note that that's my final answer, and people can look at it and say, yes, they know what they're talking about, they've worked everything out step by step, and they're happy that they've got there. So it's quite a straightforward question when you know how to do it. So take a little bit of practice, but we keep practicing. Try it yourself, have a go at the question, change the scenario, change the number, change the length of the cables, change the size of the cable, change your resistance, change your impedance value, make your own questions to suit this scenario and keep practicing. You'll get there. It just takes practice and getting used to finding everything in the regs. This is really straightforward. It's the usual R1, R2 tables in the on-site guide and the disconnection times and the ZS values in the main regulations. You can't really go too far wrong. Hopefully this video helped you get along, and hopefully you fly for your exam and you get a question similar to this, which would be ideal. Thanks a lot, guys. Cheers.